Okay, what if you could generate electricity right from the air around us? I'm talking 24/7 with zero fuel and zero emissions. Now, I know it sounds impossible, right? It seems to go against one of the most fundamental laws of physics. But what if there's an exception to the rule?
Look, let's be honest. We are facing a massive global energy crisis. We need clean, reliable power for everything, for our homes, for our industries, for the whole AI revolution that's happening. But our best options right now, they're all coming up short. So that leaves us with a huge question. Where do we go from here?
Because, when you really start to look closely at our so-called green solutions, you find out they're not quite the perfect answer we were all hoping for. They actually come with their own set of really serious problems. Let's start with renewables, like solar and wind. They're great when they're working, but the sun doesn't always shine and the wind doesn't always blow. That makes them intermittent, unreliable. And to build them at the scale we need, you need vast amounts of land. That creates conflict with farmers, and it can mean destroying sensitive ecosystems. And we've all seen the pictures, floating solar farms just wiped out by typhoons. They can be incredibly fragile. Okay, so what about nuclear power? It's incredibly powerful, for sure, but it comes with these immense lingering risks. The names Chernobyl and Fukushima still send a chill down your spine, and the cleanup costs are in the hundreds of billions of dollars. And we still, to this day, have no real permanent solution for storing radioactive waste that's going to be dangerous for tens of thousands of years. In today's world, nuclear plants have even become potential targets in conflicts. It's a massive security threat. And here's where it all comes together to create this global pressure cooker. So many countries depend on energy imports, which makes them vulnerable. Our electrical grids, a lot of them are ancient, and they're just buckling under the strain of renewables switching on and off and the soaring demand from new tech like AI. It all just makes our climate goals feel more and more out of reach. We are seriously caught in a bind. So, to find a way out of this, we've got to think differently. I mean, really differently. And that means we have to go back to the basic physics that governs all energy, starting with one of the most ironclad laws in the entire universe.
This is it, the second law of thermodynamics. Now, at its heart, it's pretty simple. Heat naturally flows from a hot thing to a cold thing, never the other way around on its own. And every time this happens, the total amount of randomness, or what scientists call entropy, in the universe goes up. For more than a century, this law has set the absolute limit on how efficient we can be.
And listen, this isn't just some minor guideline. The famous physicist Arthur Eddington called it the supreme law of nature. It's treated as unbreakable, a fundamental truth of reality. But what if it wasn't completely unbreakable? What if a constant, universal force, something like gravity, could create a tiny loophole, an exception to this supreme rule? This, right here, is where things get really, really interesting. It turns out the answer might have been hiding in plain sight, in a nearly forgotten experiment from over 100 years ago. It might just hold the key to turning heat directly into electricity in a way we always thought was completely impossible.
So the story starts way back in 1910. A physicist named R.C. Tolman is spinning a vial of electrolyte fluid really, really fast, and he notices something weird. It generates a voltage. He figures it's just a temporary fluke, some kind of polarization, and he just dismisses it. Now, fast forward over a century, a researcher named K.T. Chen has a wild idea. What if gravity itself could give direction to the random jiggling of molecules? So in 2022, his team runs the experiments, and they prove it. The voltage wasn't a fluke. It was stable. It was real.
So how on earth does this work? Well, it's actually pretty intuitive when you break it down. First, gravity does what gravity does. It pulls the heavier positive ions down a tiny bit, so the lighter negative ions kind of float on top. Second, this separation of charges creates a stable electric field, basically a voltage, just like in a battery. And now for the magic ingredient, heat. The normal ambient heat all around us makes the ions constantly vibrate and jiggle. This jiggling pushes them against that electric field, which continuously recharges the voltage and lets a steady electric current flow. Okay, so this is the crucial point. The system is taking the random energy from heat, just the normal heat in the room, and turning it into a useful directed electrical current. And it's doing it all at one single temperature. This flies in the face of Carnot's theorem, a pillar of physics, which says you must have a hot place and a cold place to get any work done from heat. This says maybe you don't.
Now, a claim that big, a claim that rewrites the textbooks, It needs extraordinary proof. So, has this crazy idea been put to the test? And what could it actually mean for us in the real world?
Well, let's talk about proof. It starts with this number right here, over 5,000.
That's the number of physics and chemistry professors all around the world who were sent the research and were personally challenged to find a flaw, to poke a hole in the theory or the experiments. And so far, not a single one has been able to definitively prove it wrong. Think about that. That's some serious peer review. And it speaks volumes about how solid this idea is. You know, the lead researcher, Katie Chen, said it perfectly. He's not trying to start a fight with 150 years of science. He's basically saying, look, I know what the belief is, but my evidence suggests there might be an exception under these very specific conditions. It's humble, it's scientific, and it's all about following the data, wherever it leads. And this isn't just some theoretical curiosity either. It has real-world potential. The calculations show that a system built with common materials could generate a stable 72 watts of power for every cubic meter.
So let's connect the dots here. This would be a form of energy that needs no fuel. It just pulls power from the heat that's already all around us. It would produce zero pollution, no carbon, no radioactive waste. Remember how we talked about renewables being intermittent? Well, this would be 24/7 power. It's like having a battery that is constantly being recharged by the world itself. It neatly solves the biggest problems we have with both renewables and nuclear. So it all comes down to this incredible question. Could a little-known phenomenon, spotted over a century ago and then forgotten, actually hold the key to a whole new era of clean, limitless energy? It just goes to show you sometimes the biggest revolutions don't come from inventing something new, but from looking at something old with fresh eyes. The question isn't, is it possible anymore? The question is, what do we do with it now?